Okay, so to continue on from yesterday. Last thing we did was we looked at having 5 rectangles of equal width, right? If we want to be more accurate, you want more rectangles. It was in the same space. You want technically an infinite number of rectangles. So that's where this formula comes from. So if you have an infinite number of rectangles, that's what the n represents, and the summation of all those rectangles. Now, this deals with your left boundary and your right boundary for x, those two vertical lines that your values, that your shaded regions between. So you just take the first one plus the differences of those two over n, and the difference of those two over n again with the I in there. Okay, so this formula will actually give you that structure. So you don't always have to figure out exactly, okay, what value do I need specifically to get the thing to be the correct height of rectangle for each one? Well, this just compensates for that. Okay, so yes, you do need to know that formula. So, looking at this, if I have this problem, I want to find the area of the region bounded by this graph of 2x squared and the x-axis between 0 and 1. So what's 2x squared look like? Parabola opening up. This is limiting you to the first quadrant between 0 and 1. Okay? So if I look at this curve, it's not locking, right? Okay. If I look at this curve and I go between 0 and 1, it's actually talking about this shaded region here. Okay, because your rectangles are so small, it actually, instead of being a bunch of rectangles, you actually just have a shaded region on the actual graph. So what I want to do with this, I want to take the limit as n goes to infinity, so as many rectangles as imaginable, actually more than that. The summation is I goes from 1 to n, and that'll always be the same thing. And then I'm going to take my function. But when I'm going to plug into the function, I need to figure that out. So that's where I use the formula. So what's your a value in this case? What's your 0? So I'm going to have 0 plus, what's your b value? So I have 1 minus 0 over n times I. Admittedly, you could skip this step and don't bother with the zeros in there. Over here, the width of each rectangle is going to be 1 minus 0 divided by the number of rectangles. Clean it up a little bit. If you actually started at this point, that would be fine. So the 0 plus isn't going to matter. I'm just going to end up with 1 over n times I, and then times 1 over n. So if you started at that point, that's fine. Does it make sense how I got to that? So now take the 1 over n I, plug it in for x. So I still have the limits, I still have sigma. Plug that in, I'm going to get 2 times, I'm just going to actually write that as I over n, for simplicity's sake, squared, times 1 over n. That one's not too bad. Clean it up, multiply it all out, what do you end up with? Two I squared on top, and the third on the bottom. Okay? So then, pull out your constants. So I pull out, what are the constants in this case? 2 over, remember, n, even though it doesn't look like it, is technically a constant. That constant is going to be infinity in a minute, but it is a constant. And I'm left with inside just I squared as I goes from 1 to n. So I can replace the sigma I squared. What's going to go in place of sigma I squared? Yeah. At that point, clean it up, multiply it through. I'm going to have 2n times, when I FOIL that out, 2n squared plus 3n plus 1. And I have 6n cubed on the bottom, and then distribute. Or if you want, you could actually just simplify at that point. Either distribute or simplify it. If I simplify it, that's going to leave me 3 and 1. Anything else I can simplify? N with one of these n's, leaving it with n squared. So, as simplified as I can get it, I'm going to have 2n squared plus 3n plus 1 over 3n squared. So what's the limit going to be as n approaches infinity of that? 2/3. That is the area of that shaded region.
On the right column, the 2 over n cubed, so I should take that part to the front.
Because what I want to get here, I want to try to get just sigma of one of those 4 things that were back here. I want to have just sigma I cubed, sigma I squared, or sigma of just a number. So I'm removing anything else that's in the way, because once I have that, I can just substitute in one of these 4 formulas. Yeah.
Could you bring the limit of 2?
Could you have distributed this? Yeah. You could also, because if you look at it, what happens? If I were to go off to the side here, if I were to multiply this all out and not simplify anything, I would get 6n cubed on the bottom. On top, I would get 4n cubed plus, let's see, that'd be 6n squared plus 2n. And if you look at that, if you take the limit as n goes to infinity, you're going to get 4 over 6. So you'll get the same thing. Just kind of which way is easier for you. They'll both work. Yeah?
Okay, we go back to that first one. So, like, when we went from F to, like, not having F anymore, what happens there?
So, this is I over n, right? That I'm substituting into the f function. The f function they give me up here.
Okay.
So I'm plugging that value into 2 times whatever squared. That's where that's coming from. Yeah? That formula. Okay? The a value is your left bound, the b value is your right bound, everything else is just n's and i's. Okay? Anything else? Okay. Now, this process, one of these problems will flat out be on the test. Okay? Good news is, everybody should at least have the right answer for it. Bad news is it's going to take me a long time to check because this work is hard to follow. The reason everybody should have the right answers on it is because if I put y equals 2x squared into the calculator, this function, right? And then graph it. There's your parabola, right? I'm going to zoom in just so we can see what area we care about, because I don't care from 0 to 1, right? So I want that shaded region. Well, the nice thing is, on your calculator, if you go to second in calc, this symbol here, kind of an elongated S-looking thing, is actually the symbol for integration. Derivative is kind of where you spend most of your time for Calc 1. Integration is where you spend most of your time for Calc 2. It's actually what we just did. The lower limit on this problem is what?
1. 0.
0. What's the upper limit?
1.
What do we find for the area? 2/3. If all you have listed as the answer and your work doesn't back it up, I will give you 0 points. Oh, we could always just do no calculator on the test.
No, it's okay.
That's me.
Okay. But this is a good way to check your answers if you have specific numbers for boundaries like that. Okay. Your turn. Show me the work, too. Give you a couple minutes. Okay, let's look at it a little bit. Some people are still in process, and that's fine. Let's take a look at it. Okay. So I plug in the lower bound and the upper bound, the 1 and the 3, and then let's clean it up. So limit is n approaching infinity. Sigma I is, the sum as I goes from 1 to n. F of, and this isn't going to be pretty, but it'll work, 1 plus 2i over n times 2 over n. Okay? Now, I'm going to plug in just this portion here that's inside the f function into the f function. So limit n approaches infinity of sigma I goes from 1 over to n of 4 times 1 plus 2i over n minus that 1 plus 2i over n squared, all of that times the 2 over n. It's one of those things, you want to be very systematic when you're doing it. Now, distribute and clean it up. We'll deal with the limit and the sigma stuff later. So since we'll deal with it later, I'm going to shorthand them. So, distribute FOIL 2i over n plus another 2i over n is going to give you 4i over n. 2i over n squared is going to be 4i squared over n squared times 2 over n. Anybody follow me to there? Okay. So, limit, sigma. Here I'm going to combine like terms. So I'm going to realize this minus. This is a common mistake, guys. Make sure you realize that minus is distributing. 4 minus 1 gives me 3. 8i over n minus 4i over n is just 4i over n. And negative 4i squared over n squared. All of that is times 2 over n. Then distribute. So the limit, sigma 6 over n plus 8i over n squared minus 8i squared over n cubed. Then what? Split them up with the sigma, yep. So I'll still have limit. The sigma now starts mattering, because remember they're all from 1 to n. Now what I'm going to do here when I split this up, I'm actually going to pull out the 1 over n here. This just sometimes makes this a little more clear. And then there's a 6 there. So you have 1 over n in front of that sigma and then the 6, because that looks a little bit more like that sigma c. Because that n can throw you. If you leave it there, it's fine, but... And then over here, what am I going to take out of this one? Eight over n squared, yep. Leave just the I squared. And what am I going to take out of this one? 8 over n cubed. Sorry, thank you. Don't do that kind of mistake. What was I saying here? To n. And that's I squared. Does that make sense? Now replace. The 6 just becomes what? Yeah, ultimately, it'll be 6n, which will turn into 6, yep. So limit, I don't have to clean up the rest, so I'm going to actually leave that complicated because I know I'm going to have to clean up the rest. So I'm going to have 1 over n times 6n plus 8 over n squared times sigma I, oops, sorry, I can't see that. Sigma I is just going to be that n times n plus 1 over 2 minus n cubed, replace the sigma I squared with n times n plus 1 times 2n plus 1 over 6. Okay. Sigma 6. Why is it 6n and not what? It will be in a second. I left the 1 over n there, just so that the pattern's consistent, because I left what's out front. If you have 6 there, that's perfectly fine, because that's what this will simplify to in the next step. Okay. Okay. So still limit as n approaches infinity of, that will just be 6. This, if I FOIL it out, or multiply it out, I should say, will give me 8n squared plus 8n, because that 8n will just distribute over 2n squared. Now you can simplify if you like, you don't absolutely have to. Minus, if I distribute all of this, it'll take me a couple steps, but 8n, and then this will be 2n squared plus 3n plus 1 over 6n cubed. Distribute that through the top. That's going to give me 16n cubed plus 24n plus 8n, sorry, that's n squared, over 6n cubed. Limit as n approaches infinity. Finally, I can actually do that limit, because I have those separate terms. I'm going to apply the limit to each piece. What's the limit as n approaches infinity of 6? 6, yep. What about for the next fraction, the next term here? 4, because the 8n doesn't matter. 8n squared over 2n squared is just 4. Minus 8 thirds. 16 over 6 simplifies down to 8 thirds. Simplify it, 10 minus 8 thirds is? In other words, 30 thirds is minus 8 thirds is? $22 thirds. Questions? Well, this is only one of them on the test, right? Yes, you do. So, this gives you a lot, if you look at this homework section, this gives you a lot of opportunities to do this kind of problem. Practice them. Test is when?
Friday.
Friday.